Hello, hi, good day, everyone. Decided to share a funny with you. I hope you like it. If not, let's move on. So here we go. Today's objective is for you to be able to solve a quadratic equation by factoring. So today we're going to do some factoring, okay? Factoring will be with us for a while, including when we come back from the break, all right? So don't forget what you learned, okay? If not this ed puzzle, like your teachers will be there for you. We will. So here we go. To solve a quadratic by factoring, we write the polynomial equation ax squared plus bx plus c equal to 0 in factor form and solve using the zero product property. So what's the zero product property? I'm glad you asked. Here we go. Boom. In words, come on, 0, number 0, product, multiply, property. A statement, a rule, if you will, a theorem. In words, if the product of two expressions is 0, then one or both of the expressions equals 0. Algebraically, if a and b are expressions and a, b equals 0, then either then a equals 0 or b must equal 0. Okay, what that mean in short? Hey, 3 times 0, 0. 4 times 0, 0. 0 times 5, 0. Okay, we can keep on going. If you multiply and your product equals 0, one of those terms have to equal 0. That's all that means. It's just fancy words. We got to get comfortable with words, people. Okay? So let's get into what we're doing today. How are we solving quadratic equations? What are we going to use? Let's do some work first. But first, here we go. Example 3 says to solve a quadratic equation by factoring. So you're given x squared minus 4x equals 45, and you want to solve that by factoring. Okay, here's the thing. We started off factoring. We started off solving quadratics by graphing. We put them on a graph, and when we put the equation on a graph, do you remember what it was that you look for as the solution to a quadratic on a graph? I need you to answer that question. Okay. If you just said the x-intercepts, you remember the 4 words, okay? So it is your x-intercept that represents your solution, which represents your roots, and it also represents your zeros. And that's why we talk about the zero product property today, okay? So we have graphed them. We have also solved quadratics by using square roots, okay? But notice, here's what we have today. We have in today's equation a linear term. What do I mean by a linear term? You see this 4x right here? That's a linear term. How would you know that? Because that famous equation that you all remember, y equals mx plus b, something x. This is something x, so that's your linear term. The x squared represents your quadratic term, okay? 45 is our constant. Okay, enough of that. Well, you're probably saying, why we got to learn how to solve a quadratic by factoring when we already know how to graph it and we also know how to use square roots to do so? Because you got to learn it. Do as I say, not as I do. Just playing. I'm serious. Okay. But why? Because you need another form to put in your toolbox. You're not always going to be able to graph it quickly. You're not always going to be able to solve by square roots. Okay. But you can use factoring as an alternative method. Okay. To solve a quadratic. So let's talk about what we did before. And if you did not do the lessons previously, you may want to go back and look at those. Not may, you do, because you need to start doing your work and turning in your stuff on time, peoples. All right. So, this is what you had before. Notice here, is there a linear term? Do you see something x? No, you don't. You see something x squared, quadratic. Look here at b, 3x squared plus 9. Do you see something x? No, you don't. You see something x squared. That's quadratic. There's no linear. Look at C. Something X? Because X is being added to 3 and squared. Still not linear. Okay, so notice that with these problems, all you had was an X squared and you had a constant. Regardless if it's on the left or the right side of the equal sign, that don't matter because we saw yesterday you can move things around. And you know how to move things around. But anyway, I'm stop talking. Here we go. Back to our regular scheduled program. What are we doing today? Solving quadratics by factoring. So that's a bunch of problems. Yes, the TLs. Okay. We're going to do a few together. And then you're going to do a few for practice. Okay. I'm going to introduce you to something. And I hope it works. And I hope it helps you. Give me a moment to get things set up for you. Hey folks, so a duplicate of what you just seen on the slide. What we're going to do first, we have to always figure out what is A, what is B, and what is C. This here is your complete setup for how we are going to factor a quadratic. Okay? Now, I know it may look confusing. There's some spaces and stuff like that, but some of you maybe can pause and try this on your own. Okay, eventually in the next couple minutes you're going to try it on your own. The first thing that you have to figure out is what's A, B, and C. Just to review in case you are new, A, B, and C comes from knowing okay, this is standard form for a quadratic equation. If you have your equation in standard form, you can always identify what is in the place of A, what's in the place of B, and what's in the place of C. In this case, we have 1, 16, and 39. If you need some help with getting those numbers, let your teacher know. Okay, so the first thing that we need to do here, once we identify A, B, and C, you can go to your setup chart. Okay, we need two numbers that's going to multiply and equal A times C. A times C in this case, 1 times 39. It's going to be 39. I need two numbers that's going to multiply and equal 39. Then I need the same exact two numbers to add and equal B. B in this case is 16. Okay, so if you don't know what those numbers are off the top of your head, and this is why I say multiplication is very, very, very important. Okay, to figure out what our factors are, we can do just write down what multiples give you 39. So start with 1. 1 times 39 is 39. Is there any way that you can add 1 and 39 to get 16? Because we want to be able to add these to get 16. No. Okay, 2 does not work. It's not even. 3 times 13 would give you 39. 1 over 39 did not work. These two will add and give you 16. So in this case, our factors are 3 and 13. You always need to go back and see if that will be true in both cases. 3 and 13. 3 times 13 is 39. 3 plus 13 is 16. So we did good. So now, because both are positive, my factors are when x plus 3 and x plus 13. So this equation in standard form is equivalent to what we have here. X plus 3 times x plus 13 both equal 0. What I was pointing out was that the original equation we started out with and this equation are both equal. Just as a review, the equation that we started out with is in standard form. Form. My R and my M connected. So this is in standard form. The equation here is considered to be in intercept form. Okay, so why does all of that matter? It'll come up in a little bit, okay? I promise you. But we're not finished here. We know our factors are x plus 3 and x plus 13. Now what we need to figure out, because it says solve, we need to know what does x equal. To figure out what x equal, we need to first consider x plus 3 equals 0. That's that zero product property. And then x plus 13 equals 0. Now, we consider both cases. Here we go. We need to make 3 disappear because it's by the x and we're solving for x. To make 3 go completely away, we'll subtract 3 and we end up with x equals a negative 3. Okay, over on the other side, same process. Because we had a plus 13, we'll do the inverse and subtract 13. So x will also equal a negative 13. Okay, now this is my solution. In this case, we have 2 solutions. We can even write it as a set, negative 13, negative 3. If you're going to write it as a set, make sure you use a curved bracket, because if you use parentheses, it's wrong. That's a point, okay? This right here represents a solution. Don't forget that. That was way back in the beginning. Now, one other thing to put some things together. I'm going a step further. Let's be clear. What you have here is your answer. You are done. Once you get to this step, what you see highlighted, you finish. But of course, Ms. Gable's doing the most. So let me help you out. Let's just say you want to know how to check your work. Okay, you got options. Remember in the beginning when we graphed this? I'm not going to graph this perfectly because I took my time and I did a lot of graphing the other day. So I'm going to say that negative 3, 0 is there. And I'm going to say that negative 13, 0 is somewhere over here. The y-intercept will be somewhere way up here at 0.39. If you don't know how I just got 0.39, talk to your teacher. All right. If you don't know how I got 0.39 and you in my class, say something, baby. All right. So that graph would look something like what you have here. Not even going to do a solid line because my graphs be awful. All right. But what I want you to notice is that if you were to graph this, then you see that your solutions will be the same. Another thing that you can do, if you wanted to check this, you can put both x plus 3 times x plus 13 inside whatever graphing feature you have. And then you can also put x squared plus 16x plus 39 equal y into that same graphing, whatever you're going to use, decimals or the 83 or whatever other thing you got. All right. And what should happen is that these two graphs will overlap perfectly. Okay. If there's anything off or movement to the side or up or down, you did that incorrect. Okay. And don't forget another way. So you can graph it and check it in 2 ways, for your intercept as well as to see if you did this portion right. And then the other thing that you can do, I'm going to do a throwback right quick. Okay. Now, depending on what school you came from or what district or whatnot, you may have used the box or you may have used foil. If you don't understand how to get what I just got, talk to your teacher, okay? Because it's the same thing here, okay? If you don't understand this box, say something. If you don't understand how to graph, say something. If you don't understand why these are equivalent, say something. If you don't understand why this is the solution, say something. In the end, what I need you to do, say something, baby. Thank you. Let's get ready for the next one. Here's your chance to do number 2. If you feel like you don't got it, say something. I'm about to set up for number 3. Now, folks, I just set up for number 3. Why did I choose to do number 3 instead? Well, because number 3 don't look like number 1 and you need to practice on number 2. Okay. So, some things to point out to you before we get started. You see this equation? Does it have a linear term? No, it does not. Okay, so if you're familiar with what we did yesterday, you can do this in 2 steps. Okay, let me show you. Do it, and then I take it away. Why did I do that? Because I want to show you that both ways will work with that one problem. Okay, now here's the thing. You probably saying, well, Ms. Gable, they don't have a linear term, so what am I supposed to do? Ax squared plus bx plus c equals 0. Okay, we definitely know that a is 1. We definitely know that c is negative 100. We don't have a term for b. What are we going to do right here? You don't have nothing there for b. You have nothing there. B is 0. 0 times x is 0. Okay, let's get started. Now, with a negative 100, sometimes we got to deal with negatives. Okay, I'm gonna exaggerate this a little bit just to make sure we're on the same page. I can multiply 1 times a negative 100, or I can multiply negative 1 times a positive 100 and get a negative 100. You with me? But if I add those, I forgot to set up that part. Excuse me. Over here, we're looking for 2 numbers that multiply and give you negative 100. But the same 2 numbers have to add and equal 0. You might already have it. If so, good. Go ahead, pause me, figure it out. All right, we can do 2 times a negative 50 or negative 2 times 50. There's no way I can add that and get a 0. Okay, I'm going to skip down past 4, past 5, and go straight to a negative 10 times a positive 10, or a positive 10 times a negative 10. Okay, either way. We try it out, see if it works. A negative 10 times 10, that's 100. A negative 10 plus 10, that's 0. So that lets me know that in my I left off another word. I can do x minus 10 times x plus 10. Okay, so we just went from standard form and now we're going to write this in intercept form. Okay, I know that I'm throwing some vocabulary at you, but I feel like you can handle it. Okay, something about you told me you can handle it. X minus 10, x plus 10 equals 0. These 2 equations are equivalent to each other. If you don't believe me, multiply that using either the box or FOIL, first outer inner last. Woohoo! All right, so now what we must do is consider x minus 10 equals 0 and also x plus 10 equals 0. Okay, now what happens in this case, we have a minus 10. We must do the inverse and add 10 on both sides. So x equals 10. Over here we have a plus 10. So we have to subtract 10 on both sides, and x equals negative 10. Okay, to go back to what you saw on a post-it note, and pause that if you need to see that. Okay, so what you have on a post-it note is a plus or minus 10. What you have as your solution here is a plus or minus 10. These two are both the same answer. So what that means is that if you were to graph this, and I'm not going to graph this because I already showed you how to graph. And if you don't know how to graph it, say something. All right. These 2 numbers here in both cases, what are the 4 words that they represent, people? I'm going to pause it because you're going to answer the question. And then I'm going to show you what the answer is. Well, one of them is the x-intercept. It's the intercept form, so x-intercept. That's what it tells you. This represents your solution, your root, and your zeros. Well, I could have put that without the parentheses, but that's what it represents. Your intercept, your solution, your roots, your zeros. That is in both of these cases. Okay, people? Now, You're about to practice and do one on your own, okay? Good people, so here we go. X squared minus 17x minus 60, same steps. 1, negative 17, negative 60. Two numbers that multiply and equal negative 60. Same exact two numbers must add and equal negative 17. How do we figure out what those two numbers are? Start off with negative 60. I'm not going to do positives and negatives. That would take too long. 1 and 60, 2 and 30. Any way we can add or subtract those and get 17? Nope. 3 and 20. Add or subtract, give you 17. Boom, boom. Now what you have to figure out, is it going to be, you need 3 and 20 to add and give you a negative 17. Which of those numbers would have to be negative? Would negative 3 work? Or would negative 20 work? Which one would work? I borrowed $3, I pay you 20. I still owe you? Nope. This is what works in this case. So 3 times negative 20, that's a negative 60. Positive times a negative. 3 plus negative 20. Same sign, add and keep, different sign, subtract. Keep the sign of the higher number, then it will be exact or correct or whatever your teacher taught you. Plus 3 minus 20. It works. So, your intercept form of this equation is x plus 3 times x minus 20 equals 0. What is your solution? I'm glad you asked. X plus 3 equals 0. X minus 20 equals 0. Subtract the 3. Add the 20. X equals negative 3. That's one of the solutions. X equals 20. That's your other solution. It would intercept the x-axis in two places. We're going to kick it up a notch. Good work. I'm not going to let it go to waste. Here we go. X squared plus 16x equals negative 39. I put this here on purpose. You want to see why? This right here is not in standard form. It does not equal 0. How do I get this to equal 0? What is it that I need to do with 39 on both sides? I must add 39. 39 does not have an x or x squared. So I'm left with x squared plus 16x plus 39 equals 0. I wonder what the solutions are. Ta-da! Okay, so it's the same process. Even though we have negative 39 on the other side of the equal sign, you must make sure that every time you're given an equation, before you try to factor it, it must be in standard form. Write that down because I'm about to ask you. Must be in standard form every time. Let's look at something. What you gonna do first? What form does it need to be in? It's in standard form. What you gonna do now? What A, B, and C is, what are you gonna do now? Set up your graphic organizer to figure out what two numbers multiply and give you A times C, and the same two numbers gotta add and give you B. What are you gonna do now? Figure out what two numbers multiply and give you negative 48 and a positive 2. Then you add them. Now what you gonna do? Equations in intercept form. Now what should you do? figured out what your solutions are. How can you check them? Graph to check your solutions, or you can multiply to check your intercept form. Either way. Okay, so you have some practice to do with this. Solving by factoring. If you have any questions, please don't hesitate to ask people. Thank you very much for your time. I hope that you all have a great day. Bye-bye.